Today we're going to look at the Suvat equations. There's a velocity time graph. And this is what Suvat stands for, all these components. And we've got 4 equations. And these all stand for an object moving under constant acceleration. So we've got initial velocity, 10 meters per second, acceleration of 2 meters per second squared, and we're trying to find the final velocity, and it's going for 20 seconds. So I always put the Suvat down and then fill in the bits I know. That's the distance, which we don't know. Right, that's our starting point, initial velocity. We are looking for the final velocity, 2 meters per second squared for acceleration, and our time of 20 seconds. Now we look for the right equation. We can't use anything with s in it because we don't know it. So we've only got this one here. V equals u plus at. Put in the bits we know. And we can calculate the final velocity. Done. We got another one. Same thing, ball rolling, 50 seconds, 40 meters per second for our initial and 60 for the final, and we've got to find the distance. So I'll always put a question mark for the thing we're looking for. Put in the bits we know. We don't know acceleration, so we're not going to be able to use an equation with a in it. No. Yes, that one. If we look at this, this is basically the average velocity times the time. So if we look at this top triangle there, that would fit into this space over there. Fifty times 50, 5 5's 25, 2 noughts. Done. Another one. What have we got here? Okay, we've got all these bits were put in. We've got to find the distance again. The velocity is unknown, Okay, so that means, looking at my way of doing it, we can't use an equation with v in it because it's unknown. Not that one. Not that one. Not that one. Must be that one. Right, do a bit of cancelling there. $200, yeah. 10 squared, 100 times 10, 1,000. Done. Alright, we've got to find the final velocity of this one. And we don't know t, do we? Right. $10. V is unknown. That's the thing we've got to find. I'll better put a question mark there in a minute. Can't use anything with t in it. We're looking for v, Stephen. Come on. It's better. So nothing with t. Nope. 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 Yes. Put all the bits in. Ten squared, 100. 2 15s, 30 times 50. 3 5s, 15. 2 noughts. 1600. And the square root of, let's see. Well, the square root of 16 is 4, so that's going to be 40, isn't it? Done. And these are slightly more difficult, I think. They're more difficult really because we're going to have to move the equation around. Because we've got to find acceleration. There's no equation that just gives acceleration. Put in all the bits we know. Keep to a system. That's what we're looking for. Acceleration, and it goes for 10 seconds. So let's have a look. We can't use anything with s in it, can we? No. No. That's going to be that one. But this time we're going to have to move this equation around to get a on its own. And I've got a video on how to transpose formula I'll put a link to it. So I've moved the u over to the other side, and now that's times in by t, so we've got to divide by t. Right, that's got a on its own, so that lot will equal a, so we put it all in. 40 minus, what is it, 10 over 10, yeah. Okay, that's that one done. This one we've got to find two things. Got to find u, initial and final velocity, and all we're given is the distance, 150 meters. It goes acceleration of 2 meters per second squared, and time is 10 seconds. Okay. Let's have a look. We can start with, we can't use the first one. Can't use the second because it's got u and v in. We can use, yes, this third one, I think. And that will at least find the initial velocity for us, but again we've got to rearrange this equation, transpose it for u, the initial velocity. So I'm moving all of that half at squared over because it was adding, and it's now gone to negative to the other side. Now that t is multiplying all of this, so multiplying the initial, so we divide it, and that gives us the initial velocity. I'm going to put all the bits in this side. Let's see what we come up with. 150 minus 100. Okay. Over 10. Oh, it's going to be 50 over 10, isn't it? So our initial velocity is 5 meters per second. Okay, we've got that bit done. Now we have to put that initial velocity into another equation. Stick it up there for now. So, and we've now got to find the final velocity. Oh, we can use the first one. Yeah. Done. Okay, well I think that's it for today. Hope you've all found it useful.